Well, I welcome you back, and we are starting from where we stopped in the previous video. I promised you that I'm going to come up with more cases, and I'm left with after this I'll be left with one case for simple connections, and this is what we are going to do. We are considering a particle of mass m2 kilograms, but this time resting on a smooth surface of a plane inclined at a certain angle alpha to the horizontal and connected by a light inextensible string that is passing over a smooth fixed pulley at the top of the plane of mass m1 kgs hanging freely. Let us find the parameters of acceleration, tension, and maybe actually the normal reaction. Looking at this, I need to first sketch. This is my plane. And doing my plane, it is inclined at a certain angle, alpha, and then here is placed my body of mass m2 kilograms. So if it is mass m2 kilograms, this is m2g. It has got normal reaction R, and we need to know that for this case, if the plane is inclined at angle alpha, we need a resolved components of this weight. So we shall have a component m2g, because alpha, they have to be imaginary, so don't draw them using solid lines. We draw them using dotted lines, and mind you, you need to be too careful. One can leave them, one can draw imaginary lines, but the problem with leaving them is that during the resolution of forces and other operations, students normally forget them, so better show them. And here we shall have m2g sine alpha. Then, of course, this is the tension T. Still, I'm going to assume that m1 is heavier or is bigger than m2. So if I put here my mass 1, so the weight will be m1g, and this tension is still the same T. Since it is considered to be heavier, the system will be accelerating downwards, and this one will be moved upwards. So the acceleration is that way. Now, let me operate these masses respectively. So I'm beginning with m1 kilogram mass. For m1 kilogram mass, the resultant force is going to be m1g minus t, because it is accelerating downwards, meaning that this weight is heavier than t. So we shall have m1g minus t. I'm applying the conditions that I showed you in the first video, where we were like the forces in the motion of the bodies counterbalances the forces in the opposing motion. So here, that's why we have m1g minus t. So that my overall equation will become m1g minus t is equals to, this is F is equals to MA, which is M1A. I call this one my equation 1. For case of M2, kilogram mass, since it is moving this way, it means that T is counterbalancing this. This T is moving in the direction of motion, while this M2G sine alpha is in its own direction, implying that the resultant force is going to be equaling to T minus M2G sine alpha. Then the overall thing is going to be T minus M2G sine alpha. This is the force F is equals to MA, which is M2 times acceleration. Now, by adding 1 and 2, if you add equations 1 and 2, we are going to have, we are going to have T and T will cancel because this will be minus T plus T, it will cancel. So we'll have M1G minus M2G sine alpha is equals to M1A plus M2A, which will be M1 plus M2A. Factorizing out a G here and dividing A, rather M1 plus M2, both sides you shall have A as G into M1 minus M2 sine alpha, everything over M1 plus M2. Now, with this case, you can easily get your T or the tension by substituting in any of these equations. For example, you can substitute maybe in equation 2, A into equation 2. When you substitute A into equation 2, you will be having T minus M2G sine alpha is equals to M2 times A, so it will be M2G, M1 minus M2 sine alpha out of M1 plus M2. So this is going to be T is equals to M2G sine alpha plus M2G M1 minus M2 squared sine alpha G out of M1 plus M2. Looking at this, we shall have our T as we are multiplying this into this because it's the LCM, so it is going to be M1 M2 G sine alpha plus M2 squared G sine alpha plus M2 G M1 minus M2 squared sine alpha G. Everything is over M1 plus M2. MG2, the squares will go, so we shall have T as M1 M2 G sine alpha, M2 M1 G. So we shall factorize out M1 M2 G. So I'll be left with sine alpha here plus M1 M2 G. So it will be 1 now. Everything out of M1 plus M2. As simple as that. Now, my next thing to do would be to show you how we get the normal reaction of this. So to get the normal reaction of this, we are going to apply parallelogram law of forces. And having known alpha, we can complete this triangle very well, and we apply the parallelogram law of forces, and then we get what normal reaction is equal to. Allow me to do this. Now we are having, for the reaction on the pulley, we just get it by applying parallelogram law of forces. And basically, I'm going to draw something simpler for us. this one being 90, this one being alpha, would imply that this one is the same as 90 minus alpha, 90 minus alpha. So having this, shall have a normal reaction, and here I'll have tension, and also here what is considered my resultant will be tension in the stream. So by definition, program law of forces formula will state that R squared is equals to T squared plus T squared plus 2 times T cos 90 minus alpha, because the reaction is acting with respect to this angle 90 minus alpha. Since we know the expansion of cos, it is going to be easier for us, so we shall have R squared as 2T squared plus 2T squared cos 90 minus alpha. But we know cos 90 minus alpha is the same as cos 90 cos alpha minus sin 90 sin alpha. Remember, sin 90 is 1, but cos 90 is 0. So my R squared, let me say my R is going to be the square root. Sin 90, since sin 90 is 1, so it is going to be 2T squared plus 2T squared sin alpha. Why am I doing this? Remember, the expansion here of cos 90 minus alpha from your pure mathematics supposed to be cos 90 cos alpha plus sin 90 sin alpha. Cos 90 is 0, so the whole of this one becomes 0. Sin 90 is 1, so we shall remain with sin alpha, which is this. So it would imply that my R is going to be equal to the square root. I can factorize out 2T squared being common, so 2T squared into 1 plus sin alpha. So my R, or the normal reaction, is going to be equal to, T is the only one with a square root, so it will be T into the square root of 2, 1 plus sin alpha. That is what we have as our normal reaction. So a case comes in now. The other one was case A. Maybe let me call it case A, because now I'm going to bring in a situation where I have where I have a rough plane. So for the case of a rough plane, if you consider a rough plane, this is where we are going to find ourselves with the frictional force on a plane opposing the direction of motion of these masses. So if we have, ensure to use a ruler. So if I put my body there and I hang my mass, if my mass still is m1g, or rather my weight, and then this is T. So this is the same as, since it is still heavier, the acceleration, it will be accelerating in this way. So I'm having my other mass, it is saying kind of angle alpha, the plane. So if my mass is still m2g, rather my weight is m2g, and the normal reaction is R, I will have m2g cos alpha, and for this case, the component is going to be m2g sine alpha. But remember, the body is accelerating these ways, implying that the frictional force is opposing the motion of the body and it is acting downwards. The moment you come to know this, then the rest becomes very, very easy. So for m1 kilogram mass, you can get the resultant force as m1g minus t, implying that the whole thing is going to be m1g minus t is equals to m1a. Then when you consider m2, the resultant force is going to be t. Since the system is accelerating these ways, so t would be counterbalancing the summation of these two. So it is t, the one which is pointing in the direction of motion, minus f plus m2g sine alpha. So that the overall thing becomes force, which is t minus f minus m2g sine alpha is equals to m2a. Working on it, it will become t minus mu r minus m2g sine alpha is equals to m2a. But remember r, when you look at the diagram very well, r is counterbalancing m2g cos alpha. So we shall substitute for r as m2g cos alpha, implying that my equation will be t minus mu m2g cos alpha minus m2g sine alpha is equals to m2a. Call this one my equation 2. So if I add 1 and 2, I'll be having t will go with the t, so I'll be having m1g minus mu m2g cos alpha minus m2g sine alpha is equals to m1a plus m2a, which is m1 plus m2 times a. Looking at this one here, you can factorize out. You can factorize out. Can factorize out so that well, we shall have our g outside. So I will have my acceleration equaling to, if I factorize out g, to be m1 minus mu m2 cos alpha minus m2 sine alpha divided by m1 plus m2. So by having this, we are safe to go. So I'm going to look at my last case, then I do illustrative examples for each case. From each case, we shall do an illustrative example, but after I have done case 5. So for case 5, we're going to consider two particles of masses m1 and m2 resting on smooth faces of a double inclined plane All right, and are connected by a light inextensible string passing over a smooth fixed pulley at the vertex of the plane. Right? I will say that if these faces are inclined at angles alpha and beta, to the horizontal, respectively, with M1 greater than M2, let's find the acceleration of the system. This is very easy after having understood what you have to do. So here, use a ruler and draw your double inclined plane. Incline this face at angle beta, again this face at angle alpha. Of course, we are going to put mass 2, and we are going to put mass 1. So looking at these masses, if this is mass 1 kilogram, so this will be M1G. And as usual, it will have the resolved components and the normal reaction R. We call it R1. And here, we shall have M1G cos alpha. And here, we shall have M1G sin alpha. Some books don't show these forces, the resolved forces. Don't blame the books, the imaginary forces, but you have to calculate while using them. So here, if this is the mass 2, it will be M2G, the weight. And then here, I'll have R2. This will be M2G cos beta. But remember, the faces are smooth, so we don't have any frictional force. And here it will be M2G sin beta. We have tension of the string. We have tension of the string. But remember, M1 is greater than M2. So the system is accelerating these ways. Now, if you look at for M1 kilogram mass, it means that still we shall have, now it is this weight, this force M1G sin alpha, which is counterbalancing the T, because it has to accelerate downwards, meaning this force is greater than this. So it will be T minus M1G sine alpha, that is our force, is equals to ma, which m is m1 times acceleration. For m2, since it is moving these ways, so it will be t counterbalancing m2g sine beta, so it is going to be t, or no, for the first one, no, it's supposed to be m1g sine alpha moving the t, so it will be minus t here. But for m2, it is now t that is moving the m2g sine beta upwards to equal to m2a. Equation 2. When you add the two, when you add equations 1 and 2, it will be m1a plus m2a, which will be a into m1 plus m2 is equals to t and t will cancel, so I will be having m1g sine alpha minus m2g sine beta. I'm looking for for a, so a will be going to m1 sine alpha minus m2 sine beta times g. I factorized it out of m1 plus m2. As simple as that. So I want us to look at a case where there is frictional force acting on these faces. A case where frictional force is acting on these faces. So for rough planes, I'll be having my pulley, and my bodies. Use a ruler for each drawing you make. So there is tension. These strings. Remembering that this is inclined at alpha, this is inclined at beta, and this is m1g weight. This force is m2g sine alpha. Well, this is the reaction 1. This is m1, sorry. So this one will be m1g cos alpha. Similarly, if this weight is m2g, it has got the normal reaction R2. And this one here will be m2g cos beta, whereas here we shall have m2g sine beta. Because it is accelerating the direction is this way, is accelerating this way, and this one is accelerating this way. Remember, our m1 is still greater than m2. So if this is accelerating this way, then its frictional force, I'll call it F1, but in that motion. Because this is moving downwards, so the frictional force is upwards, but on the plane, not on the string, on the plane. Frictional force must be acting on the force. Rather, that force should be acting on the body of contact, that is the plane. Then this one is moving upwards. It is being pulled, moving upwards from this motion. Therefore, its frictional force, let me call it F2, will be moving these ways. Now looking at this, I can talk about M1 kilogram mass. For M1 kilogram mass, you can really see that the resultant force is going to be equaling to, I'm on M1. This is M1 G sine alpha, but opposing the motion of the tension and F1. So it is going to be M1 G sine alpha minus the summation of these two. So minus T plus F1. This is M1 G sine alpha minus T minus F1, which is mu R1, which R1, because F is equals to mu R for your own information, F is mu R. So instead of R, actually we have mu R1 because this is F1. So mu R1 is already M1G cos alpha. So mu M1G cos alpha. So that the overall becomes force M1G sine alpha minus T minus M1G cos alpha mu. I call it equation 1. Then when I go for M2 kilogram mass, still the resultant force is going to be equaling to, now this T is moving direction, in the direction of motion, T minus in opposite direction. So it will be M2G sine beta plus F2. So this is the same as T minus M2G sine beta, then minus mu R2, because F is mu R. So if it is F2, then it is mu R2. Coefficient of friction on the same plane is the same. So we shall have R2 as M2G cos beta mu M2G cos beta. What does it imply? It would imply that the force T minus, oh, this one I forgot to make it an equation. So it is going to be equal to M1A, so that it becomes my equation 1. Then for this case, it will be T minus M2G sine beta minus mu M2G cos beta is going to be equal to M2A. Now, looking at these two equations, when you add 1 and 2, if you add equation 1 and equation 2, you're going to have M1G sine alpha minus T. I'm adding them, but a T and a T will cancel, so I'll have minus M2G sine beta, M2G sine beta, T has gone, so we shall have minus M1G cos alpha mu minus mu M2G cos beta is equals to M1A plus M2A. So overall, it would imply that when you factorize out here, the A is going to become M1G sine alpha minus M2G sine beta minus M1G cos alpha mu minus M2G cos beta mu, everything out of M1 plus M2. So that is acceleration. Now, this is where we are stopping. In our next video, I'm going to do you the illustrative examples and we see how it can be done. I wish you all the best. See you in our next video.